We can have 30 minutes to discuss about all the presentations today. Yeah. So please, if you have any questions, raise your hand or just simply unmute your microphone and ask.
Very quite simple knowledge today, yeah, but I think it's better to give you basic knowledge and gradually induce this passive sampling technique. But we are always doing both. Huh? You
Yes.
always need to do both to compare.
Okay, I think
No
it's
questions.
yes,
Crystal
yes.
clear.
Yes.
No.
Can I have a question to you, Professor
Yeah.
Gao? Yes.
Yeah.
In order to have a representative sample, usually how many sample and which location do you sample?
I think we are quite luxury this time. Huh? I think for each sampling station, for water sample, for DGT, we deploy 6.
6.
Yeah. Sometimes you can deploy 12 if you are rich.
But
you are right to get a reliable result. Statistically, you need at least more than 3. Yeah? But you are right. Sometimes the result can vary a lot because sometimes the turbulence of the water flow can make your sampler maybe short time at the back or short time in front. So, but that's why this time we supply Hong the plate. So all the samplers will face in the same direction.
But can you give some detailed information about the station in the river? Because we need to take samples from the river, right? To analyze heavy metal or microplastic, for example.
Yeah. Microplastic we don't do.
Okay, even you don't do the microplastic, but for the heavy metal in the river,
Yeah.
how many sample do we need, and which station, which place in the river we need to take?
I think each site. Now we decide how many sites. Hong, I forgot 6.
Yes. This time we will take a sample from 6 different stations. I mean 3 from river and 3 from the ponds, a fish pond.
And I said each time we need to carry out classic methodology to guide the dissolved concentration, total concentration, then to guide the particulate concentration. At the meanwhile, we deploy DGT to measure the bioavailable concentration, or we say to measure the time integrate concentration. So it's paralleled protocol. And water sample, we take 3. Each station, we take 3 samples. Filtered, unfiltered, I said we take 3 samples. But the DGT, I think each type you get 6.
Yes, this time we get 6. 6 different locations, and in each location we will take the filtered sample and unfiltered sample, and also DGT.
Yeah. Did I answer your question, Doctor? I cannot see his name, Dr. Duan. Did I answer your question?
Yes, yes. Thank you. Yes, that's fine with me.
I don't think DGT has been used for microplastic, but I know DGT has been tried for nanoparticles.
Thank you, Dr. Gao, for the answers.
You are welcome. Very good question. Yeah.
May I ask question just concerning about some of your first slides about how say the water quality after wastewater treatment plant and
You're interested about that.
So I just wonder that
You can apply a project in Vietnam, huh?
I just wonder that in Belgium, do you have kind of monitoring the level of different toxic substance after the wastewater treatment plant?
Actually, the wastewater treatment plant, there is we call it Aquafina. This is the name of wastewater treatment plant. They do their monitoring, but you know they are not a chemical laboratory, so they won't really measure all. We want to know all the trace metals we did like you analyze in water, cadmium, lead, copper, nickel, zinc, iron, manganese, everything. And we also analyze some specific organic pollutants, EDCs, PAHs, and I think PCB dioxins are also included. Then at the meanwhile, we also measure the bacteria level. You know, domestic water will maintain a lot of E. coli and also other type of bacteria. So we're also measuring that. But it's not one group with a different institute. We are doing together. But Aquafin won't, for example, measure all the time copper concentration, cadmium concentration, nickel concentration, zinc concentration in the effluent. The environmental agency, they are measuring I think once per month. It's a kind of monthly monitoring in the surface water. Actually, this effluent water at the end, I will show you tomorrow, at the end enters to the surface water. It's directly discharged to the surface water. But to be honest, the metal concentration are not high because it's domestic water, it's not industrial water. But some of organic pollutants are high, E. coli level are high, you know, so that's quite normal, yeah.
But because I mean that if the level of different toxic substance in effluent water is low enough, then it's okay to apply that water to irrigation the crop.
Yeah, that's the purpose of this project, to open a door to the farmers. But we didn't dare to do directly in Brussels. We choose wastewater treatment plant in a very remote area, and where the agriculture soil surrounded this wastewater treatment plant. Then we may do directly irrigation. So now next step is to use the water for the irrigation now.
Okay. Yeah. Okay, so is there any questions or comments?
No questions?
No. Yes. So yes. So there is one Khương.
Yes. Thank you. I just have a small question. Just follow the question from Dr. Hương, and I want to ask a question that because domestic wastewater is not truly domestic wastewater, right? Sometimes some factory or manufacturer they also discharge some industrial wastewater into the domestic or into the domestic wastewater. So, like after the like in the final of domestic wastewater treatment plant, do we need to control some like some heavy metal, some heavy metal concentration after the domestic wastewater plant before we use for the irrigation? Yes.
If I say the situation now in Belgium, is not necessary. I think the industrial wastewater has been controlled very strictly here. They're not allowed to join the domestic water discharge. But in Vietnam, I think it's possible. And
Yeah.
if it's in that case, before the irrigation, you really need to control because this is environmental impact. And the water you will do the irrigation logically, if you think it has a chance to transfer to the crops you are going to grow up. So means they will accumulate in the food chain. So if it's the case in Vietnam, I think you should do the monitoring. And I had a paper with my former postdoc in China, and he analyzed some organic pollutants in, they are very high in the effluent water. I think trace metals could be, but in Vietnam could be a concern. But in a lot of other countries, probably organic pollutants are the most toxic ones. Why? Because organic pollutants can be from your, shampoo, body care, everything you use daily. So that's produce the big source of organic pollutants, both inorganic and organic pollutants. If in some countries the industrial discharge join with domestic water discharge, should be careful.
Oh yes, Professor. So like because like I have some a little discuss like in Vietnam. I know in Vietnam like take some industrial zone, they are do not separate the good like the line of domestic wastewater and the line of the industrial wastewater. So just have to say that we need to truly to that monitoring that.
I think you touch a quite sensitive question, no?
Yes,
you need to discuss with the government also, and also the regulations for the industrial.
yes, yeah, just like my concern. Yeah.
Yeah, sure. We should think about that.
Yeah, thank
really.
Professor for the answer. Yeah.
Very interesting question. Yeah, indeed.
Yeah. Thank Professor.
Thank you.
Yeah.
Okay. So we still have 15 minutes to go. So if anyone has any comments and questions or
yeah, you are welcome.
You're welcome, more than welcome.
No, crystal clear.
Okay.
I think my students also can explain why. I hope they can.
I mean, this is common procedure for chemists. I mean, for the one who do chemistry study, but for the other people, it's quite very new.
Yeah, I understand that. That's why I introduce simple things and induce the technique we use. And I think it's easier tomorrow for Martin and I to go very detailed information. Yeah. Because tomorrow will be more difficult to understand maybe. Yeah.
Yes, and also.
But I think Go ahead, Hong. Yeah.
I just want to mention that if you just do the taking the sample from the field and do the analysis and without caring about the strict procedure, how to do it correctly to have the reliable data, then it's useless to use such data. So it's very useful for not only the one who work with the environmental issue, but also for others who want to try it. So I think
You know, if you don't carry out the procedure correctly, you will get a lot of questions when you submit to journal.
Exactly, and also the data will be how to say kind of yeah. For me, it's not it's waste of money and time. So
Yeah. But it's okay. Yeah, it's okay now. Yeah.
as you said, that it's about 60% of time is sample preparation, yeah, sample processing. So just
Yeah,
6%.
then there are about 30% of data treatment and the result interpretation. It's also take you a lot of time to do that.
Yeah, only
Yeah.
6% of sample collection and 6% of how to say
Instrument help you in one day. You have 200 sample analyzed. Professor Gun, he has another question. Yeah, go ahead.
Okay, so sorry, I just have one more question, because that related to my previous research. Like when I do some, because I know professor have some like experience about the ICP, right? ICP, the analysis for heavy metal, and I have some like the aqueous sample. So do I need to store the sample with strong acid before using the ice?
You have water sample,
Yes, the water sample.
acidified.
and
Like
if you, as I said, depend on what you want to get. If you want to get total concentration, you do immediately acidification. But of course, if you didn't do, you may still do now. But you try to, shake very well. You probably will lose something.
oh yeah.
But if you want to do dissolve the concentration, dissolve the concentration is more linked to bioavailable concentration. That you need to do immediately after the filtration in the field. You better do that, because this wastewater treatment plant, one of my PhD students, I give you an example. She did what? She did total acidification in the field. And she did the syringe filtration in the field. She acidified these two samples, but she transferred a big bottle of water sample without any treatment back just in a day. I think it's 7 hours or 8 hours after sampling to the laboratory. She did the filtration. Then she analyzed the dissolved phase and the particulate phase. Those results are completely different from the field results.
Yes.
So what does that mean? Some of metals has been absorbed on the container, and you do the filtration, you lose those absorbed on the container. So her result after this vacuum filtration were much lower than the concentration she obtained in the field. But we need the filter because we need the exact concentration of the particulate phase. So now that's why I say she bought a portal vacuum with her every time she goes to the field. She does the filtration in the field. So you better acidify it if you want to analyze total. If you want to analyze dissolve, do the filtration immediately, acidified also.
But like, because we know that the instrument is not it often far from the field sample, right? The sampling area, right? So we need time to take the sample to the lab to analyze
the analysis. But after acidification is stabilized, it can be you keep it at 4 degrees. Keep it in the fridge at 4 degrees. It can be for 2 months. I know not all the time the instruments are ready for you. So you need to wait 1 month or 2 months. So if you keep your sample, I mean ICD-5 sample, in the fridge, no problem at all. Because
So maximum.
Hong,
Yes, yes.
yeah, Hong is going to storage the sample also before she can post to us. And she will ICD-5 the sample and storage in the fridge.
So maximum we can store it in the fridge for 2 months?
Yeah, I will say
Almost.
that I will not make it too long. If you put it too long, I don't know. Some of element are stabilized at certain pH for a long time. Some not. Then you probably will lose also. But our experience, we don't like it exceeded more than 2 months in the lab.
Oh yeah, Professor. Okay, I got it. Professor, because that is
But
related.
I think there is no strict requirement. For example, you do 3 months, probably still okay.
Because
Yeah.
I know that the ICP is very sensitive for analyze the heavy metal. So I think the store method is quite important for ICP as well.
Yeah, because it's not only the sensitivity of the instrument, it's the good way, suitable way to keep your sample. Because even the instrument is sensitive, but you did something wrong on your sample, you won't get good results. That's a
Yes.
pity. That's really a pity. I hate that because you spend a lot of energy to take the sample and at the end, off. Yeah.
Yes, yes, I got it. Oh yes, I got it. Thank you, Professor, very much. Yes.
You are welcome.
Yes.
And I think also we have to pay attention about the materials of the bottle to store the samples. You cannot
Yeah, you
use
have to use suitable material. For metals, okay, you can use polyethylene, polypropylene, those plastic ones you can do, but you have to acidify. That's very important, acidification of your sample.
and I prefer
And
to
organic pollutant sampling, you have to use glass. You cannot use any plastic.
cannot use plastic. Yeah, if you
Yeah.
work with persistent organic pollutant, so you have to use glass.
Yeah.
Okay, so it's very interesting to discuss about the methods because it's all very, how to say,
Yeah, you saw I wrote and I highlighted something so there. But home 22nd and 23rd, I will be with my iPhone. You know, with my phone, I always have internet. I hope you also. If you have any questions when you taking sample, call me.
I can call you if I have any problem, but I hope that it will be okay. Just I think I just worry about the COVID situation, but nothing else. I hope that if we come there, if no one stop us to sample and do some
Yeah.
something like that.
Okay, yeah, that's something we cannot change.
Yeah.
Yeah, that's a pity, really. Yeah.
So we prepare almost everything up to now, and I have received the thing you posted the day before yesterday.
The bamboo bar, the stick, I think you better take strong ones. Don't lose it, and then you cannot find them back anymore.
I have asked my student to go to the field last weekend already. So he worked with the local people and to ask them to prepare us the bamboo stick and also the fishing string for
Yeah. And don't touch the surface. And the probe, the sediment probe,
yes.
the marker for 2 centimeter, that's important. You have to leave it. You cannot insert completely. Then we don't know the depths. So that's important also. Okay. Yeah, I think we are almost there. And
Yes, so if you don't have any questions now, thank you very much, all of you, for the time. And tomorrow we still have a lot of interesting presentations concerning about the technique of using DGT, and also we will show some results from our previous project. So I hope that you will enjoy another day with us before we go to the field and to do the real practical thing there. So I will show you how to deploy the DGT to the water and sediment. So thank you.
Thank you very much. Thanks to everyone. And see you tomorrow, because topics are very interesting tomorrow, I think.
Still to come very interesting thing we set for the last.
Yeah, okay.
Thank you. See you tomorrow.
Thank you, Ding. Thank you, Hong. Thank you, everyone there. And thank you, my student, to wake up very early.
Thank you.
Okay, see you. Bye-bye.
Bye-bye.
Thank you. See you.
Thank you. Bye. Bye.
nhỏ tiến độ tận 6 giờ thôi.